probability. So before we can really talk about probability, guys, we're refocusing, please. Thank you. All right, probability. First of all, we can't talk about probability without first discussing events. An event is any chance process. But I want to make sure we understand something here, okay? Because if I ask you what are some examples of a chance process, you might say rolling a die. Or you might say, I don't know, flipping a coin. Or doing something like taking cards out of a deck. And those are chance processes, but those are like instructional chance processes, okay? Or there's something we use in a game, like when we play board games to make sure a game is fair. But like when I go home today, I'm going to go through 4 stoplights, and every single one of them is a chance process. It's a process that has a probability attached to it. When I go to the light at 5th and Northwest today, what are some possible outcomes when I go to the stoplight at 5th and Northwest? What could happen when I get there? It could be red. It could be yellow. It could be green. All of those things are possibilities. The light could be out. There's a 4th one, right? Do you guys get what I'm saying here? If I randomly select a page out of this notebook, what's the probability that there is writing on it? It's pretty high. There is, right? Okay, but you guys get what I'm saying? That's a chance event. If I look out the window right now, what is the probability that a middle schooler is straggling late? Right now, it's not happening, but is it a possibility? Okay, thinking about sports. Baseball. What happens in baseball?
You hit the ball.
Maybe you hit the ball.
You catch it.
Is there, but like when a batter goes up, when somebody's at bat.
You're more likely to not hit the ball. Honestly, you could.
When somebody's at bat, is that a chance process as to whether or not they get a hit? And people who are more skilled at baseball have higher probabilities of getting a hit. That's a for sure thing. You know who has a terrible probability? This guy. Do you guys get what I'm saying now? So probability has all sorts of implications. It's not just basic probability stuff, like spinners and all the stuff that teachers tend to have to teach you probability. Everybody okay? All right. Now, an outcome is a possible result of an event. Now, if we did that simulation with the dice once, where everybody did it once, do we know how many, would we know how often we got the number of winners? Would that percentage change if I did it once versus 10 versus 20?
Yes.
Would the percentage change, or would it just get more consistent? Like the first time I did it, we got 16%. The second time I did it, we got 15%. The next time I did it, we got 13%. Then you guys were 11%. And if we did it again, we could get... I don't think it would be. I think it would go back up probably to around 12 or 13%. Okay? And, I got a better idea. You guys remember Joy? Not Joy. Lady Adeline?
Joy.
I mean, no. You guys are going to meet Joy in Unit 6.
Oh.
Sometimes I use Lady Adeline in Unit 1 and Joy in Unit 6, and then I do vice versa. That's what I was doing. Okay, so hold on. 1 out of 1 didn't convince you. 2 out of 2 didn't convince you because you said that could be chance. Okay. Probability events, chance behavior is unpredictable in the short run. Here's what I mean. I could go grab one of those die, and I say, what's the probability I roll a 1? And I could roll it. If I roll, like, on any given turn, you guys would not be comfortable saying how often I was going to roll, whether or not I was going to roll a 1. Is everybody with me? But if I rolled that die 600 times, and I asked you to approximate how many times I got a 1, you would say about 600 times. I chose 600 for a reason, you guys. Yeah.
You gotta record. Oh, yeah.
I did hit record. You guys were late, but I remembered to hit record.
And so did I.
Good job. No, you're tardy. Okay. Let me say this again, you guys. Short run, any one time I roll that die, very unpredictable. Is everybody good? But if I rolled it 600 times,
100.
you would think about 100. So it's very predictable in the long run. I know what's going to happen if I do a chance event a lot of times. And in fact, when we went and the first time we all went through and said how many times we won, we weren't convinced by it. But the minute we all started doing it a bunch of times, we had 100 different trials of doing that, then we started to feel pretty good about what was happening. Does this make sense? Okay? So when estimating that probability, I'm going to ask you guys, we're going to do the most basic probability calculation. I do have all sorts of die. I've got 4, 6, 8, 10, 12, 20, and 100-sided die in this room at different points. Okay? The blue ball there is the 100-sided die. It's cooler in theory than it is in practice because you roll it and it rolls and rolls. Like it takes forever to actually land. This is my 8-sided die. Pretty cool, right? All right. And so if I asked you to tell me what is the probability I roll, a 1 or a 2 on this die, what would you say?
12.5%. Oh, no. 25%. It's 1.
The first thing I would expect you to tell me is you, of course, would not tell me anything without showing me where it came from. So you're not going to just tell me a number. You're going to show me how you got that number. So what would we need to ask ourselves? Well, we would say, how many die, or how many sides of this die are labeled with a 1 or a 2? What is the answer? 2. 2 out of 8. So I'm hoping we're all hearing that the fraction itself needs to be there. Okay? And then you could actually leave it as 2 out of 8 as long as you're not trying to do something later with that probability. Okay? If you're trying to make comparisons, you need to get it into that decimal or percent form so that you can actually compare two things. All right, so one goal of that question was, do you know how to calculate simple probabilities where we do desired over total? And I've had very few students been like, that doesn't make sense to me. Okay. Because you guys have been doing this for a while. All right, now, if I asked you to interpret that, like what does that probability really mean? That's where we come to a sticking point. Guys, if I ask you to interpret it, I don't want you to say the probability is 25%, which, believe me, doesn't feel like it should be an interpretation that kids give, but it does. It is. It's what people tell me all the time. Okay? We're going to go right back up to this idea. Okay? When does probability actually have meaning? In a large number of trials. Okay, so to interpret probability, if we roll the die a large number of times, we can expect to land on a 1 or a 2 approximately 25% of the time. That's definitely a large number of times. Now, if you don't include the phrase large number of times, you're going to get a P. And you're going to get really mad at me for giving you the P. But is it fair for you to get mad at me when I'm telling you not to do it? You got to include that phrase, large number of times. Everybody good? Yeah. Can we roll? Okay. So, if I ask you now to define probability, can we define probability now without using the word likelihood or chance or odds? We could say, hey, it's if I did something a lot of times, it's the frequency with which it would happen. Everybody good? It's the frequency over a large number of trials. That's what likelihood really means. So, definition of probability is that, first of all, it's a number between 0 and 1. I shouldn't have to say this, but I am. If you tell me that the probability of something happening is 1.2, you will get an I, not a P. Does everybody understand why I might do that? That shows a very, very large misunderstanding about probability. All right. That describes the relative frequency of an outcome in a very large number of trials. How we feeling? We okay? All right. So, insurance companies, warranty companies, all of those things operate on probability. How many of you have your driver's license? Guess what? Your car insurance costs more than mine. Why? The insurance company has huge amount of people. And for an auto policy, that huge number of people is a large number of trials. And they can say, what's the probability you get into an accident? And for your subset of people, it is much larger than for my subset of people. Does that make sense? Cool. All right. Now, we're going to use this idea on a phone warranty. And yes, I know it's a stupid example. If I leave the cost of a phone at $150, I'm on it. Okay? Let's go ahead and say a phone costs $150. And the company who makes that phone, they know what percent are going to get turned in. You want to know why? How do they know? They've got a large number of people who've used their phones. Do you guys see what I'm saying here now? Okay? And what is each phone for a warranty is a chance process. Is it going to break or not? And because it's a large number, we could say for that, the cost of a phone's $150, but if only 5% of people break their phone, do they need to charge for the warranty 100% of the cost? No. They charge 5% of the cost. So let's go ahead and talk about Leo. Leo is a very irresponsible kid. He would definitely break his phone, right? And he knows that, so he's going to buy the warranty. He's been picking on me all day. I get to pick that, right? Okay. So Leo buys the warranty. He breaks his phone. He turns it in. What's going to happen? If you're the company, what happens? You're losing money because you're losing essentially $142.50. Is everybody good with that idea? So why would they do this? Yeah. Let's talk about Logan. He's a very responsible kid. He would never break his phone.
Thank you.
Yeah. Yeah. And so, but Logan, he paid the $750. And not just Logan. Aiden's the same way, right? He didn't break his phone. Right? Ellie, you didn't break your phone, right? So they break even at, like, for that large number, if for every one, 19, if for every one that breaks, 19 doesn't, they're going to break even. And for a large number of trials, it's going to hold, that probability is going to hold. Everybody good? All right. Here's my favorite question. Works every time. All right, guys, I'm going to put 5 different possibilities for flipping 6 coins. Or flipping a coin 6 times. Which one is more likely?
Gotta be tails.
Even with the ones I added in. Heads, 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 heads. Tails, 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 tails. Here's the, you guys.
Tails is on a hot streak at the end of that first one.
These are all the same probability. Now, y'all think that when patterns exist, something's not random. If I were to seriously, what if I just added some in between? Heads, tails, tails, heads, tails, heads, 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 tails, heads, tails, 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 heads, tails, heads. Right, and guys, I really was trying not to think when I did that. All of a sudden, if I look at this long string of these, you guys with me? This doesn't bother me as much, right? Now, if I flip that coin, one coin every time, any one permutation of that would have the same probability. But if I took 6 coins and flipped all of them at once, you guys with me on this? Okay. 6 coins flipped all at once, I would be more likely to get 3 heads and 3 tails. Because there's a lot more ways to get 3 heads and 3 tails. Like, for instance, this way, and this way. But there's only one way to get 6 heads. Does that make sense? Okay. But any one of those equal probabilities. And what we think about randomness is not really great. Okay, we tend to say, oh, if we see a pattern, there's no way it could be random. That's not true. Because to try to make something without a pattern, you end up making a pattern. Cool? All right. The other one that people tend to have major misunderstandings about is something called the law of large numbers. The law of large numbers is in fact true. It says in a large number of trials, a probability should hold. And that is in fact true, but that's not how people use it. So here's my example for this. Let's say I'm flipping a coin, and I already know that my first 8 flips were heads. There are people who will say that the next time I flip that coin, I am due for a tails. You guys get what I'm saying here? Hey guys, what's the probability on that next flip I get a tails? Am I now more likely to get a tails? No. Well, this one is 50-50. It's okay when it actually is a 50-50. Technically, it's like 0.499, 0.499, and 0.001 or something. Like if you,
it doesn't land on either side.
Yeah. Like you can, because you can stand a penny up on its head. It's just incredibly, incredibly unlikely. But theoretically, you could do it. Everybody good? So, when you're listening to a sporting event, okay, And I don't know, it's something like the NBA Finals, and they're saying, man, Steph Curry, he's missed 3 of his past 4 free throws. He's due to make it. No, he's not. His probability of making it is the same it was, whether or not he made those 3 or not. Because those 3 already happened. And when we're talking about somebody's next attempt at something, how many trials is that? 1. If Steph Curry's going up for his next free throw, that free throw is, in fact, 1 trial. So regardless of what's already happened, that one event is only one event. People lose not billions. People lose lots of money on the lottery because they're like, man, I'm due to win. Are you ever due to win the lottery? No. Yeah. Everybody good? Okay. Let's talk about a few more things. So we already kind of talked about the answer to probability. Guys, I'd really love it if you could, pay attention. Okay? The answer to all probabilities has to be between 0 and 1. Probabilities also have something called a sample space. And all a sample space is the entire set of outcomes. So the sample space for flipping a coin is heads, tails, and technically landing on its side. The sample space for this die is 1, 2, 3, 4, 5, 6, 7, 8. The sample space for me pulling up to a traffic light is red, yellow, and green. We get the idea of sample space. So the probability that something in the sample space will occur is 1. That makes sense, right? In other words of saying that is all probabilities should add to 1. All right. Speaking of Steph Curry, did I ever tell you guys that I used to play basketball? I was a very specific kind of basketball player.
Could you dunk?
Yeah, with my 5'1" frame. Mm-hmm. No, in fact, if I shot the ball, my coach pulled me out of the game. Every player has a role on the team. You guys know what I'm saying here, right? You guys get what I'm saying? Mine was not an offensive role. I was really good at breaking the press because when you're 5'1", your center of gravity is pretty low. Okay? And I was a pretty decent defender. So my probability of making things in general has never been good. Sophia, Elise in particular, watch out here, okay? Allie, maybe. I have been missing to the left, so you guys will probably be okay. So here's my question. Let's go ahead and pretend that the probability that Miss Meister makes it is equal to 0.15, which, by the way, is very generous. Okay? You think I can do it?
Yes.
Of course.
Really, please keep your eye... when I say keep your eyes open, just be alert, okay? I'm trying to get... I'm worried about the distance here, too, right?
Okay. That was to the right.
That's
Of
a
us.
mistake. You got the sink.
The distance was there.
I don't know why I am so bad at this, but I will get closer, and I'll still miss from here, and it's just whatever. All right.
From deep.
There. Okay, you guys, if the probability I make it is 15%, what's the probability I miss?
0.85.
Oh, whoa, guys. Remember, you got to tell me how you're getting these numbers. You can't just write down a number without telling me where it came from. And probability is the one unit where people really mess up on showing their work. And they get dinged for no reason. So I'm going to do 1 minus 0.15. Are you okay? Are we okay with that? Which is, in fact, 0.85. Is this okay? And as we talk about this, you guys, the name of making and missing, those are what we call complements. Now, the complement to getting a red light is not getting a... Whoa. Is not... The complement to getting a red light is not getting a green light. What is it? It's getting orange or green. It's all the other outcomes.
Wait, what's the orange?
I'm so ignoring you guys right now. Just keeping rolling because I'd like to get through this last example. And if you guys want to make fun of me after I get through this last example, we'll turn off the recording, and you guys can make fun of me. I'll give you about 30 seconds, and you can say whatever you want within reason. Like, don't make me go home crying or anything. Okay?
Okay.
Fair enough?
Get locked. We're dialed.
Okay. All right. So let's go ahead and say I'm picking a random student at a university. They could be in one of 4 different age groups, 18 to 23, 24 to 29, 30 to 39, 40 or over. Everybody good? Mm-hmm. And so what I want to know is when I ask, is this a complete probability model? A probability model lists all the possible outcomes and their probabilities. And if I want to know, do I have all the possible outcomes, all I have to do is add together the probabilities and see if they in fact add to 1. Do these all add to 1?
Yes.
They do. So is this all the possible outcomes?
Yes.
Yes.
So this is, in fact, a complete probability model.
Yes.
There's like a 15-year-old.
This isn't in college. This is, I guess, a college-based service organization. So from an organization. Okay. Now, if I said, what is the probability that I choose a student who's not in that traditional age group? And then I'm basically telling you the traditional age group is 18 to 23. What would you say? One minus 0.57. Cool. And, I don't know, 43%? What do you guys think so far about probability?
Are we done today?
What is probability again, if I asked you to define it?
Probability. A number between 0 and 1 that describes a relative frequency.
Okay, I mean, I want to know that you actually understand it. Yes? It is the percent something should happen over a large number of trials. Like, I can't emphasize enough. Probability is only reliable for a large number of trials. Cool.